There's this ongoing angst in the community that the labs are subsidizing us, and at some point they will pull the plug and we wouldn't have access to frontier models because they will be so expensive. There was this report by Cursor that subscriptions actually cost the labs $5,000 and not $200, that they are subsidizing us so heavily, and somewhere I also saw numbers like $14,000 and $16,000 per month. And you're thinking, it's my time now, I have to take advantage of this technology because it would get so much more expensive, but something didn't add up to me. Those were API costs. Those were not the real costs of the companies. What if their API costs have 70% margin? What if their API costs have like 80% margin? What if not only are they not subsidizing us, what if we are subsidizing them? What if you are subsidizing their research, their training? And then this feeling that something doesn't add up was amplified by the fact that I looked at the pricing of the Chinese models, and you could see that GLM 5.2, which is pretty much a frontier model, costs $1.40 for input tokens and $4.40 for output tokens. And if you compare that to OpenAI, $5 per input tokens and $30 per output tokens, there's like 5 to 7 times difference. Then there was DeepSeek that reduced the cost of their models by 70%. So I went in and tried to find out the truth. I tried to find out what is happening, because at the end of the day, we have a lot of public data. We know what are the stats of the chips that they're using. For example, this piece here, NVIDIA GB200, and doing back of the envelope approach, we can actually estimate what are the API costs for those companies. And I went ahead and I did that. And what I found is pretty surprising and pretty concerning. It's pretty concerning for everyone else because the margins are crazier than you think. So let's now back of the envelope calculate what are the API costs for the companies actually, what is their margin, and think about what this means. As a reference point, I'll be using the GB200 from NVIDIA. This is their newest rack. It has 13.5 terabytes of high bandwidth memory, which is roughly the equivalent of 500 MacBooks with 32 gigabytes of RAM. Then it also has 576 terabytes per second memory speed. This is roughly the equivalent of, I believe, around 1,500 MacBooks that use the latest chip. It can compute 720 petaflops per second, and this is that many number of operations. It has 16 zeros here, and it consumes enough electricity to power 100 American households, or enough electricity to charge your Tesla in 30 minutes. Now, this is the hardware that we are going to use. We are going to take the cost of this hardware, and we're going to compute how many input and output tokens per second this rack can actually compute. And based on that, we can calculate the cost of those input and output tokens. Of course, this would be a very ideal lower bound, so we'll account for that as well. And let me know if I'm making some mistakes here in my assumptions or understanding how the stuff works. For the calculations, I'll be using a state-of-the-art model. I'll assume that it has 10 trillion parameters, mixture of experts sparse model, something like Mythos or Spot, and it would have 300 billion active parameters. Now, we know that this rack costs around $4 million, and if we utilize that over 4 years, it means we'll be paying something like 3 cents per second. We can also estimate the power consumption, which is half of a cent per second, and it's also fair to add the operation costs, let's say $300 daily. Now, if you compute the total, that would be around 4 cents per second, and at 70% utilization, that would be around 5 cents per second, which is around $5,000 daily. Now, the question is how many input and how many output tokens can we process with this one machine? To answer this, we need to go to the fun part and understand how a transformer actually serves a request. Don't worry, I'll not be doing some crazy math here. Just on a high level, we'll understand how a token goes from a user, gets processed by the transformer and by the rack, and then goes back to the user. It is roughly a 2-phase process, and the first phase is the prefill, which means we are prefilling this key value cache, and I'll explain what this is. But whenever I use a sensor request, then the transformer computes something called KV values for every token in the request, and in order to compute those KV values, it pretty much needs to multiply every token by every active parameter in the model. So it means that we need to do a lot of heavy computation. We don't need to do a lot of memory shifting because we are just getting one weight, multiplying it by every single token. We're getting the next weight, multiplying it by every single token. Pretty much have 2 operations per weight per token. And then you have to do that 300 billion times for the number of active weights or parameters. So in order to prefill this KV cache, we know that our GPU does this number of operations, and this 7.2 times 10 to the power of 17, but actually we'll divide that by 2 because the GPU has around 50% utilization. This is the number of operation our GPU can do per second, and this is the number of operation that has to be done for every single token. 2 times 300 billion, because we have 300 billion parameters, and for every weight we have 2 operations on every single token, which means that our machine can process 600,000 tokens per second or can prefill 600,000 tokens per second. And this is the worst case because the KV cache is usually kept for at least 5 minutes. This is what Anthropic does. After that, the KV cache is deleted, which is why if you restart an older conversation, it usually eats up your limits faster because they have to pre-fill again the KV cache. Anyways, the input cost is the 5 cents that we had per second divided by the number of tokens that we can generate per second. And at the end, we have roughly 9 cents per million input tokens. This is the theoretical maximum that the labs can achieve for a model that is extremely big. Note that they probably have way more efficient model. This model is extremely big that I have assumed, but also we are running on state-of-the-art hardware, so I think it's fair. It balances out. But let's say their cost is 10 cents per million tokens, per million input tokens, and they're charging $5. This is absolutely bonkers. So what happened in the first step is that we have generated key values for every token, but now we'll use every key value in order to generate the next tokens. So the next phase 2 is called the decode phase in the transformer. In the decode phase, we'll be sequentially generating every token. Now, in order to generate the next token, the GPU has to reread all the weights, which are around 150 gigabytes for 300 billion active parameters, plus the KV cache. So we have a lot of reading and not that much computation in this phase. So the bottleneck here is memory bandwidth and not computation. Here in the first phase, we have very heavy computation. We have a lot of weights that we need to multiply. But here, for every token, we need to reread all the weights, and we also need to reread all the KV cache. And for that, we need a lot of memory bandwidth. That's why usually requests are batched, by the way, because when we reread the weights, we can compute the responses for multiple users in parallel. And that's what allows labs to be very efficient, because on a single read of the weights, they can then parallelize the computation of the next token for multiple users. Now, let's say we have a 2000 token coding request that generates 800 output tokens. So here we have 460 terabytes per second effective memory bandwidth. What we see on the spec is a bit higher, but usually we can't utilize all of that in practice. So I'm just taking a bit of a lower number here, 460 terabytes per second. Then I'm dividing it by the KV cache that we need to read, which is roughly 20,000 tokens. This is our context multiplied by the KV value for each token, which is roughly 0.2 megabytes, and we're getting around 115,000 tokens per second output. We are ignoring the weights here because they are reused for every request in the batch, and what dominates our computation is actually the KV cache for every single request, because the KV cache is different for every single request and the weights are shared. Anyways, if we use our 5 cent per second formula and we have 115,000 tokens per second, OpenAI charges $30 per million tokens, and the theoretical minimum is 50 cents per million tokens. However, this is a very small example. If we scale that for bigger context lengths, you get something like $2.40 for a 100K context coding agent, which I think is more realistic, around $2.40 than 50 cents. And at the end of the day, so what we got is 9 cents per million input tokens and $2.40 per million output tokens. This is way closer to what the Chinese labs are charging, and way lower than what OpenAI is charging. This means that our $200 subscriptions are probably not even subsidized. But I wasn't happy with the math that I did. I wanted to cross-check it with some reports. I wanted to cross-check it with some leaked information. And I did more math. I looked at leaked revenue numbers. The revenue for OpenAI in 2025 was 13 billion, and the cost of the revenue on Inference was 7.5 billion. And the reason that they have such a high cost on Inference is that their GPU utilization is super low. OpenAI specifically has bought as many GPUs as they can get, and a lot of them are just sitting idle. And that's why they're resetting the limits pretty much for no reason every time they discover some bug. And then I also looked at other reports like the state of AI gross margin. Then I looked at this article, Can AI Companies Become Profitable? And I'll link all of this in the description. The CFO of OpenAI also said that they can break even quickly and be profitable if they decide to do so. And based on those numbers, based on the reports, if you put everything together, I came to the conclusion. And I don't want to bore you here with the math, but the blended cost of the API tokens were around $2 to $3. Then I found other reports that those labs, especially Anthropic, are running 40 to 70% margin. And then I concluded that the $200 subscription for them costs at the absolute maximum probably $800 if you exhaust all of it all the time. So really, I don't think that our subscriptions are being subsidized. I think what is happening, actually, we are subsidizing them. We're subsidizing their training, we're subsidizing their research, and their profit margins are extremely big. And Anthropic are already very profitable. And a lot of the arguments for open weight models were, okay, companies can deploy them on their own infrastructure and companies can get a lot of cheaper tokens. But the thing is, OpenAI and Anthropic can already give them those cheap tokens if they decide to, if they feel threatened by open weight models. So I'm a bit concerned that at some point the frontier would be very expensive, but OpenAI and Anthropic would offer some models at a very cheap price, which would discourage the development of open weight models because very few companies would have use case for those open weight models. And I think something like that may happen here as well, where it doesn't really make sense to run open weight models because Anthropic and OpenAI would offer close to frontier intelligence for extremely good price. All right, let me know what you think about the math that I did, and what are your thoughts on the fact that those companies are running 70-80% margin on inference. Thanks all for watching. See you next time.